Hi Trigoners, so here we go for part 2 of our Notes 1.4. So we made it to part number 22. We're going to write in standard form, which is A plus BI form. So we need to do some simplifying. So notice if you have 2 minus 3i, quantity squared, that's 2 minus 3i times 2 minus 3i, and then we can distribute the 3. So go ahead and pause the video and simplify to A plus BI form. Okay, so I expanded 2 minus 3i quantity squared, ended up with 4 minus 12i. Now I squared is negative 1, so you can replace a 9i squared with negative 9. So if we collect the like terms, we could add the real parts together and the imaginary parts. There you go. Okay, so let's try number 23. This time we're going to evaluate. Everywhere you see an x, you're going to replace it with 1 plus I. So go ahead and pause the video and simplify and write in standard form. So if I squared is negative 1, we have 1 plus 2i minus 1 minus 2 minus 2i. And again, we can collect like terms, add the real parts together, and you get 0, and the imaginary parts together, and you get 0i. So 0 plus 0i. All right, here's number 24. So this one is a solve. Notice there's an equation, there's an equal sign, and x and y are both real numbers, so we need to solve for x and y. So what we might want to do first is try and compare the real part on the left side of the equal sign of the equation with the real part on the right side of the equation. So we know that 3x plus 2 must equal negative 4. Okay. Now you can compare the imaginary part on the left side of the equation with the imaginary part on the right side of the equation. So 2y minus 4 equals 6. So y is 5 and x is negative 2. Okay, so since we did that one, now why don't you go ahead and pause the video and give number 25 a try. So the first thing I would suggest doing is multiplying both sides of the equation by 1 plus I so that you do not have any numbers in the denominator. Go ahead and pause the video and give it a... Okay, so if you multiply the right side of the equation, 2 minus I, the quantity 2 minus I, by 1 plus I, you end up with 2 minus I plus 2I minus I squared. Again, I squared is negative 1, so we have 2 plus I, and negative I squared is really just plus 1, since I squared is negative 1. Okay, so we end up with 3 plus I on the right side of the equation, and on the left side of the equation, we have a real part and an imaginary part. So again, we'll compare the real part on the left side of the equation with the real part on the right side of the equation. And the imaginary part, let's get a different color. On the left side of the equation with the imaginary part on the right side of the equation. So we know that y minus 2 is equal to 1 because this is 1i. Okay, let's take a look at number 26. This one's a little different. This says solve for z in terms of I. So that means you're going to have z equals and then numbers over here and i's, but you won't have any z's on the right-hand side. You'll have all, again, you have to isolate the z. So let's take a look and see what we've got. We've got 1 minus iz. Now, I don't think you want to distribute that z because that'll just make it a little bit harder to solve later. So I think what you might want to do is add 4 to both sides of the equation and subtract the I. So over here we would have negative 6 plus 4 and 3i minus I. Okay? All right, so now I want you to think about what you might want to do next to solve for z. Pause the video and give it a try. Okay, so do you see how to get the z by all by itself, to isolate the z, you'll have to divide by the quantity 1 minus I. So you end up with z equals negative 2 plus 2I divided by 1 minus I. So go ahead and factor out a negative 2. All right, so now the 1 minus i's cancel, and z is negative 2. What I would like you to do is to go ahead and try number 27. Go ahead and formulate a plan. I think the first thing you might want to do is collect all the z's to one side of the equation. So I have 4 plus 2i z's and 4 minus I z's. So let's subtract the 4 minus I z's from both sides of the equation. So we have 4 plus 2i z minus 4 minus I z. And then let's go ahead and subtract the 7 and add the 2i to both sides of the equation. All right, so go ahead and pause the video and check your work. Okay, so now you have 4 plus 2i minus 4 minus I. So I have 4 plus 2i minus 4 plus I z's on the left-hand side of the equation. So now that simplifies to 3i z's. So your last step is to divide by 3i. Now here's the only problem. You can't leave the I in the denominator because it's a radical. So remember, you can't change the value, but you can multiply by a form of 1. So you end up with negative 4i, I squared is a negative 1, so minus 7 all over negative 3. Another way you could also write that, you could multiply by negative 1 over negative if you wanted to, so that could be 4i plus 7 over 3. Either one. So, nice job, everybody.